Hello students, welcome to mathematics class. Students, this is part 1 of the chapter direct and inverse proportion. In this part 1 we will be learning introduction part as well as direct proportion. So coming to the introduction, try to observe a situation where Mohan prepares tea for himself and his sister. He uses 300 ml of water, 2 spoons of sugar, 1 spoon of tea leaves and 50 ml of milk. Now, how much quantity of each item you require or he requires if he has to make tea for 5 persons? When he is preparing for 2 people, he required 300 ml of water, 2 spoons of sugar, 1 spoon of tea leaves and 50 ml of milk, whereas for 5 people he may require more than those quantities obviously, but how much are they each required? So you might have come across such situation where you require to find. Now I will give you another situation. If 2 students take 20 minutes to arrange chairs for an assembly, then how much time would 5 students take to do the same job? Here you might have observed more the people, less the time to complete that job. So it must be somewhere less than 20 minutes, but how much would be the time taken by those 5 people to complete? So this is another situation where you need to study. See children, we come across many such situations in our day-to-day life where we need to see the variation in one quantity bringing variation in the other quantity. Mark the words here. Variation means change in one quantity bringing change in another quantity. So you might have come across this sort of situations, and we are going to learn now studying that changes in one quantity, how will they bring change in another quantity. Now if the number of articles purchased increases, definitely the total cost also increase. When we are purchasing more the number of articles, we have to pay the more money. This is the simple logic. Another, more the money we deposit in a bank, the more interest that we earn on it. And as the speed of the vehicle increases, the time taken to cover the same distance will definitely increase. Will decrease or increase? Will decrease. What would be the example? Let me take. Suppose you are traveling from here to Almaty Dam, which is of 60 kilometers. Children, in your class 6th time you went on a trip to Almaty Dam and you thought of going it by, let's say, by bicycles. Now in class 8, maybe this 60 kilometers you may go in 5 hours. It takes more time. Though you are traveling only 60 kilometers, but you are going by bicycle, you may pedal with less speed. Suppose if your brother travels from Bijapur to Almaty Dam by his bike, maybe by Pulsar, he may cover this distance in 2 hours or at the most 1 hour. See, here the distance same, the speed is increasing. When you go by bicycle, you may take 5 hours. If your brother goes by a maybe moped, he goes with higher speed, so definitely reaches early. So the more the speed that increase, less the time it taken to cover it. So this is how I can give you an example. Children, for a given job, as the more number of workers we take, less the time taken to complete the work would be. Observe that in all these cases, change in one quantity is leading to the change in the other quantity. This is somewhere we are going to learn called variation. And how do we find the quantity? How do we find out the quantity of each item needed by Mohan, or the time 5 students take to complete the job? If this question arises, to answer such questions, we need to study the concept of variation. So normally concept of variation is subdivided in two broadly. One, direct variation, and you are going to learn that direct variation in this today's class, and another variation is inverse variation, and you will be learning inverse variation in the later classes. Coming to the direct variation or direct proportion, if the cost of 1 kg of sugar is rupees 18, then what would be the cost of 3 kg sugar? You know, this sort of questions you answer in your class 6th unitary method. So for 1 kg 18 rupees, for 3 kg it would be 3 into rupees 18. So obviously it is 54 rupees. Similarly, we can find the cost of 5 kg or 8 kg of sugar or of any quantity of sugar using the following table. Let us study that following table. Children, I have considered weight of kg in sugars in one column and cost corresponding to the weight of that kg in another column. As cost it is in rupees, as weight it is in kgs. For 1 kg 18 rupees, for definitely for 3 kgs 54 rupees, for 5 kg 5 18s are 90 rupees, for 6 kg it would be 108 rupees, and for 8 kg it is 8 18s are 144 rupees, and for 10 kgs it is 180 rupees. Children, we need to understand here and observe what is the as the weight of sugar increases, the cost of it also increases, but in such a manner that their ratio remains constant. What is this? Their ratio remains constant. For example, here for 1 kg 18 rupees. So I am taking ratio between them as 1 upon 18, whereas 3 upon 54 after cancellation gives 1 by 18 only. 5 upon 90 after cancellation by 5 gives 1 by 18 only. Even 6 upon 108 or 8 upon 144, you can find all their ratios being equal to 1 by 18. It is a constant. That is what we are talking. So increase in the quantity of sugar that we purchase increases, definitely the cost for that quantity of sugar increases, but in such a manner that ratio of their corresponding values remains constant. Now coming to the another example. Suppose a car uses 4 liters of petrol to travel a distance of 60 kilometers. So for 4 liters it travels 60 kilometers. How far will it travel using 12 liters? Now children, for 4 liters it travels 60 kilometers. Obviously for 1 liter it travels 15 kilometers. With 1 liter of petrol it travels 15 kilometers. For 12 liters it is supposed to travel 180 liters, sorry 180 kilometers. How? You know unitary method, same thing I am using. 1 liter of petrol, with that car travels 15 kilometers, with the 12 liters of petrol, 12 into 15, which gives 180 kilometers. So, the answer is 180 kilometers. Now, the question, how did we calculate it without using unitary method? Let us take here, since petrol consumed in the second instance is 12 liters, which is 3 times of 4 liters, 3 times of 4 liters. 12 is 3 times of 4 liters. Definitely distance travelled will be 3 times of 60 kilometers. So, 3 times of 60 kilometers will be 180 kilometers. See how nicely they have done. So, for 4 liters when it is travelling 60 kilometers, for 12 liters it would be, we do not know what is the distance. To find the distance, here he has used 3 folds of 4 gives you 12, definitely 3 folds of 60 supposed to be the distance, it is 180 kilometers. In other words, when the petrol consumption becomes 3-fold, the distance travelled is also 3-fold the previous one. So, this is what we are going to learn here. Let the consumption of petrol be x liters and the corresponding distance travelled by by kilometers. Now, complete the following table. Coming to the table, here petrol in liters is considered as x variable, distance travelled with that x liters of petrol is considered as y variable, with 4 liters of petrol 60 kilometers travelled, with 8, definitely 4 8s are, sorry 4 twice is 8, 60 twice it is 120 kilometers, 4 thrice is 12, so 60 thrice is 180, 4 5 times is 20 liters, 65 times would be 300 kilometers. Children, now we need to identify for 15 kilometers, sorry for 15 liters. How shall we do that? It can be done for 4 out of 60, equating it to 15 out of the distance travelled. Do you know how to travel? I mean, do you know how to calculate this? Let us say the distance travelled would be like y, that is variable y, 4 out of 60 equals to 15 upon y. Now, 4 ones are, 4 15s are. Now, cross multiplication 1 into y equals to 15 into 15. It implies 1 into y is y equals to 15 15s are 225. That means you could travel with the 15 liters of petrol 225 kilometers. So, with the 25 liters of petrol, how much distance that car can travel? You can calculate similarly how I have done in that way here. So, I will wipe out this whatever I have written. Okay. Now, coming to the, we find that as the value of x increases, the value of y also increases, but in such a manner that the ratio between x and y does not change at all, means it remains always constant. What is that constant here? Let us say it is k. In this situation k is 1 out of 15, 1 upon 15. How it has come? 4 upon 60, after cancellation 4 ones are 4 15s are, gives you 1 upon 15. You can even check it. We say that x and y are directly proportional, or we say in direct proportion if x upon y is constant. If I send this divisor to the other side, it becomes multiplicand, or we can write x equals to k into y. So, this is the definition, very important definition for direct proportion. Now, coming to the Further, formula, important formula. If x and y are directly proportional, then x1 by y1 equals to x2 by y2. So, it is also one of the important formula. Now, tell me what is x1 y1, x2 y2? Let me show you in this table. Children, here the value 4 liters in the variable x, if I consider as x1, corresponding distance travelled 60 kilometers becomes y1. If I consider 8 liters as x2, the corresponding value 120 kilometers travelled will become y2. Similarly, 12 liters is x3 and corresponding value of y to that 12 liters travelled distance 180 kilometers becomes y3. So, I can say x1, x2, x3, x4, x5, x6 are the values of the variable x and corresponding values of variable y to that x1, x2, x3, x4, x5, x6 will be y1, y2, y3, y4, y5, y6. So, this is the here I have used. When x and y are directly proportional, we can write x1 upon y1 is equals to x2 upon y2, where y1 and y2 are the values of y corresponding to the values of x1 and x2 of x respectively. The consumption of petrol and the distance travelled by a car is a case of direct proportion. It is an example for direct proportion. Another example would be the total amount spent and the number of articles purchased is another example of direct proportion. Children, let us come to the another situation where fill the following table and find the ratio of your friend's age to the corresponding his mother's age. Now, the table is your friend's age as f, mothers of your friend or mother of your friend, his mother's age as m, and you are finding f upon m, means ratio between f and m. Let us say present age of your friend is 12 years and his mother is of 36 years. Now, ratio between that 12 to 36 becomes 1 out of 3 or 1 upon 3. What would be their ages before 5 years? 5 years ago means before. You have already solved, you know very well these sort of questions. So, 5 years before he must be of 7 years old and mother must be of 31 years old. Now, ratio between them, that is 7 out of 31, it would be 7 upon 31. Is it equal to 1 by 3? No. So, you know that 7 upon 31 is not equal to 1 upon 3. Then further, after 5 years, your friend will be of 17 years old and his mother will be of 41 years old. Certainly, the ratio between 17 and 41, you know 17 upon 41, if you calculate, it will never be equals to 1 upon 3. So, children, is the age of your friend is decreasing and even his mother's age is decreasing, but still ratio of their ages is not being equal. So, we observe here increment in f is there as well as increment in m, but ratio between them is not same. So, what do we observe? We observe increment in both the quantities and decrement in both the quantities. And do f and m increase together? Yes, they increase together or decrease together. But what about, is f by m same for every time? No, not at all. That means, can I say they are there in direct proportion? Are they directly proportional? No. Here, age of your friend and his mother's age are not at all directly proportional. So you can think of this sort of situations where both the quantities increase together or decrease together, but not in the same ratio. So therefore we say they are directly proportional or not, means we say they are not directly proportional. So you can think of some other examples on your own and write it down. Children, here thus we conclude variables increasing or decreasing together need not always directly proportional. For example, physical changes in human beings occur with a time but not necessarily in a predetermined ratio. Changes in a weight and height among individuals are not in any known proportion. There is no direct relationship or a ratio between the height of a tree and the number of leaves growing on its branches. So they are not directly proportional. Think of some more examples similarly. Then here I am giving you, to wind up this class, try this. Here first try this, note down. Here observe the following table and find is, here it comes to the is x and y are directly proportional. So note down this and come out with answers. We shall discuss in our next class. So till then, take care of yourself. Jai Hind. Thank you.